In the last video, we had a look at differentiation of x to the n where the power was a whole number. In this video, we're going to have a look where the power is negative and also a rational number, and we find that the rules are exactly the same as previously. So, if we're working in terms of function f, if it's x to the n, then the derivative is nx to the n minus 1. Or if the equation has been given in the form of y equals x to the n, then our notation then is the y to x equals nx to the n minus 1. Now let's take a look at this example here. Now as we can see at the moment, we have a rational function, and we don't know how to find the derivative of that at the moment, but you can see there that if we simplify firstly by writing this as two separate fractions, so I write this as 4x cubed over x plus 3x squared over x. That then equals, we now use the indice laws, so x cubed divided by x gives us 4x squared plus 3x. So now we can find the derivative, so g dash of x is going to equal 4 times 2x to the power of 1 plus 3 times, now that's the same as x to the 1, so it's 1 times x to the power of 0, which therefore gives us 8x plus 3. Now in our next example, tackle the same, so we take a here. So it's going to be, using exactly the same rule, negative 3 to the power of x. Now subtract 1 from the power, it's going to give us negative 4. So that is then equal to negative 3. Now the question said over here, right, with a positive index. Of course, x to the 4 is 1 over times x to the 4, which we can write then as negative 3 over x to the 4. Now for b, if I start by first putting that as indice with negative power, so that's x to the negative 7. So now I can work out that the derivative then is going to equal negative 7x, subtract 1 from the power, then gives us negative 7 over, and of course x to the negative 8 is x to the power of 8. C will be f of x equals 1/3 x to the power of, then a third minus 1 is going to be negative 2/3. So that then will equal 1/3 times 1 over x to the 2/3, which then is 1 over 3x to the 2/3. And finally, d, I think we can fit d in here. We've got f to the x is equal to, now that's 4 over, whoops, something's popping up there. Okay, let's try again. So that's 4 over x to the half, which you can write then as 4x to the power of negative a half, using indice laws. So now we can work out that the derivative then is going to be equal to 4 times, now this is going to be negative a half x, then subtracting 1 from the power will be negative 3 over 2. Really shouldn't be going sideways here. So that's going to be, then you've got 4 times negative a half, which is negative 2. And then we've got times x to the negative 3 over 2, which therefore is negative 2 over x to the 3 over 2. Okay, now let's say now it doesn't matter if I use y or f of x, let's just use y for a change, equals 3x to the 3/4. So therefore dy dx, the derivative, will be equal to 3 times. That's going to be, the power comes down 3/4 x to the power of, then 3/4 minus 1 is -1/4. And then you've got here 9/4 x to the -1/4, which then is 9/4 x to the quarter, which is fine. Or if you wanted to put it into surd notation, that'd be 9/4 fourth root of x. Now this one over here, let's say we've got y equal to x to the 2/7 minus 3x to the minus 2. So the y dx will equal 2/7 times, subtract 1, so 2/7 minus 1 will be -5/7, minus 3 times, then will be -2x to the minus 3. So this is going to be then 2/7x to the 5/7, and then 3 2s are 6, plus 6, and then x to the minus 3 we can write as over x cubed. So like before, we could have stopped this previous one at that point there. If you wanted to write this in surd notation, you could have then 2/7 into, so the 7th root of x to the 5 plus 6 over x cubed. But unless told otherwise, it'd be quite sufficient to stop at that point. Okay, so now you should be able to do exercise 22A, which is negative indices, and exercise 22C, which deals with the rational indices.